Welcome to solverfy.
When we're converting between given quantities of measurement describing amounts of substances, it's helpful to draw out a roadmap or a plan to know which conversion to use when. So if, for example, we're starting off with a given quantity of moles, in this case, 8.35 moles of copper 1 carbonate. And we want to know the mass equivalent, or how many grams. To go between moles and mass, the relationship that we use is the molar mass. And we find the molar mass by using the formula of the compound and the periodic table. So to figure out what copper carbonate is, copper is Cu, and the Roman numeral 1 indicates it's got a charge of +1. The carbonate ion is CO3, 2-. So to make it a neutral ionic compound, the formula is Cu2, CO3. And then using our periodic table, we find the molar mass. 1 mole is equal to the mass of copper from the periodic table times 2. So 2 times 63.546 plus the mass of carbon, 12.011, plus 3 times the mass of oxygen. So these numbers here have all come from the periodic table as the atomic mass of each element. And so when we multiply and add them together, 1 mole of copper carbonate has a molar mass of 187.10 grams. So using this relationship, the molar mass, if we have 8.35 moles, we can change it to grams by multiplying by the molar mass. So we multiply 8.35 times 187.10, or a molar mass of a total mass of 1.56 times 10 to the third grams. So 8.35 moles is equal to 1.56 times 10 to the third grams. Another example, we might be given molecules instead of moles. When we have molecules, the relationship that we use to change to moles is Avogadro's number. Because that tells us that in every mole there are 6.02 times 10 to the 23rd molecules. And then if we want to go from molecules to grams, after we change to moles, we again use our molar mass. So in this case, we're talking about a compound called dinitrogen pentoxide. So to find the molar mass of dinitrogen pentoxide, we find the formula. We know that it has nitrogen, and the di means there are 2. It has oxygen, and the pent means 5. So I have N2O5. So we can find our molar mass, just like we did up above, by multiplying 2 times the molar mass of nitrogen, or 14.007, plus 5 times the molar mass of oxygen, 15.999, or 1 mole is equivalent to 108.01 grams. So this is a two-step problem where we first start off with our molecules. And we change to moles using Avogadro's number. 1 mole is equal to 6.02 times 10 to the 23rd molecules. And then we change to grams using our molar mass, where 1 mole has a mass of 108.01 grams. So multiplying 4.04 times 10 to the 20 times 108.01 and then dividing by 6.02 times 10 to the 23rd gives us the answer of 0.0725 grams. We may be given a mass to start with, and then find quantities in moles, formula units, and then even smaller descriptions based on what the chemical formula is. So if we have 78.9 grams of a compound called sodium perchlorate, we can find how many moles this is equivalent to. And again, grams to moles, we use the molar mass. We can find at a smaller level how many formula units this is equivalent to. And a formula unit is just the smallest unit of an ionic compound. So again, we use Avogadro's number. So before we start converting, we need to figure out what sodium perchlorate is. Sodium is an ion, Na+. The perchlorate ion is ClO4 with an overall -1 charge. So the formula is NaClO4. And the molar mass is equal to the mass of sodium plus the mass of chlorine plus 4 oxygens, or 122.44 grams. So I can convert from my given grams to moles. And because I want it in moles, I divide by the molar mass. So 78.9 divided by 122.44. And this equals 0.644 moles. To find the equivalent in formula units, I take my number of moles and I multiply by Avogadro's number. And so this equals 3.88 times 10 to the 23rd formula units of NaClO4. We can use that information to break it down even further if I want to know how many sodium ions there are. For every formula unit of NaClO4, there is 1 sodium ion. So if I have 3.88 times 10 to the 23rd formula units, I will also have the same amount of sodium ions. Similarly, for every formula unit, I have 1 perchlorate ion. So I should also have 3.88 times 10 to the 23rd chlorate ions for every same quantity of formula units. If I want to know how many chlorine atoms, if I look at the formula here, in this formula, for every one of these, there's 1 chlorine atom. So if I have 3.88 times 10 to the 23rd formula units, I should have the same amount of chlorine atoms. Or 3.88 times 10 to the 23rd chlorine atoms. If, however, I ask how many oxygen atoms there are, you can see that in one formula unit, there are 4 oxygen atoms. So that means that there will be 4 times as many oxygen atoms in the given quantity. Or 1.55 times 10 to the 24 atoms of oxygen.